This is problem number 1.60. Here, in the arrangement of figure 1.9, the masses m0, m1 and m2 of the bodies are equal. The masses of the pulley and the threads are negligible and there is no friction in the pulley. Find the acceleration with which the body m0 comes down and the tension of the thread binding together the bodies m1 and m2. If the coefficient of friction between these bodies and the horizontal surfaces is equal to K, we need to consider all the possible cases. Now, in this question, let us draw the free body diagram of all the blocks. So, weight will act in this direction, that is mg, and tension, the tension in this string will be, let us say, T1, and at this point the tension is T1, and we will also have friction force will act in the opposite direction. So let us say the friction force at this point will act in this direction. So let us say the friction force be F1. The friction force between block M1 and ground is F1, and the friction force between block M2 and ground is F2. And tension between the strings M1 and M2, we can write it as T2. So this tension is T2. We will also have normal reaction. So normal reaction will be in this direction, and at the same time normal reaction will be in this direction, and weight will act in downward direction. So weight, this is equals to m1g. So here m1 equals to m2 equals to m0. So this we are writing as mg, and at the same time here the weight is written as mg. So we can write it, their normal reaction is n1 and normal reaction is n2. That n1 equals to mg and n2 is also equals to mg. And here m0 is equals to m1 is also equals to m2. Here let us say the name of these two strings be 1 and this string be 2. We can also determine the limiting value of friction force of M1 and ground and M2 and ground. So we can write here as F1 limiting is equals to the coefficient of friction is K into mg, and F2 limiting, here the coefficient of friction is also K into mg. M0 will pull the string 1, because of which tension will appear in string 1. That is, T1 will appear in string 1. This T1 tension will then again pull mass M1, which is opposed by the friction force F1. So if the value of T1 is sufficient, that value of friction force between M1 and ground will be maximum. So if T1 is more than maximum value of friction force between M1 and ground, that is kmg, then only after that T2 will start appearing. And once the T2 will start appearing, T2 will pull the block M2, due to which friction force F2 will arise. So if T2 will be sufficient, that which is more than F2. So after that, all the blocks will move. So here we can have three cases. So let us first discuss case number 1. So in the first case, T1 is less than maximum value of F1. So the maximum value of F1 is F1 limiting. So T1 is less than F1 limiting. If this is the case, that means acceleration is equal to 0. That means M1 is not moving. At the same time, M2 is not moving. At the same time, M0 is also not moving. So in this case, M0 will be in equilibrium. If M0 will be in equilibrium, that means here the force will be mg, which is equals to T1. So here we will have T1 equals to mg. So from this equation we will get T1, that is mg, should be less than limiting value of F1, which is equals to k into mg. So this will be equals to k into mg. So mg and mg will get cancelled and we will get k should be greater than 1. So if k is greater than 1, in this case, T1 is not sufficient enough to overcome the maximum limiting friction or the maximum friction force between M1 and ground. So T2 will not appear. So that in this case, T2 will be equal to 0. Now in case 2, in second case, we will have, if this is M2 and the friction force is F2 and the tension will be T2. So in this case, T2 is less than limiting value of F2. So if T2 is less than limiting value of F2, that means M2 will not move. If M2 will not move, that means ultimately the acceleration of whole system is equal to 0. So that means acceleration of the whole system is equal to 0. Now the value of T2 will be less than limiting value of second friction force, like in limiting value of F2. So value of T2 should be less than K into mg. So this is the case. Now draw the free body diagram of M1. So if we draw the free body diagram of M1, we will have here we will have kmg, and here we will have T2, and here we will have T1. So this is the free body diagram of M1. Now here acceleration also equals to 0. That means T1 equals to T2 plus kmg. And here we will have T2 is always less than kmg. That means T1 is always less than T2 plus kmg. The maximum value of T2 is kmg. So this is always less than kmg plus kmg, that is 2 kmg. Now as acceleration is equals to 0, we have already seen that T1 is equals to mg. So T1 is equals to mg. So that means T1 is equals to mg, which is less than 2 kmg. So this will be equal to mg should be less than 2 kmg. So here mg and mg will get cancelled, and we will get k should be greater than 1 by 2. So here k should be greater than 1 by 2. So this means we already have k should be greater than 1 for case 1. That means for this case we will have k should belongs from 1 by 2 to 1. 1 by 2 to 1. So in this case we can calculate the value of T2. Here T1 is equals to mg. So we will have mg equals to T2 plus k mg, and the value of T2 will be equals to mg 1 minus of k. So this is the value of T2 in second case. Now let us move to third case, that is when acceleration is not equal to 0. So here acceleration is not equal to 0. If acceleration is not equal to 0, that means T2 is also not will be equals to 0, neither T1 will be equals to 0. Now we can apply the laws of motion along the string. So if we apply laws of motion along the string, the friction force acts between M1 and ground and M2 and ground will be maximum friction force. So the only force, so here we will have the free body diagram like this. This is the free body diagram. Here we will have only two opposing force, that is k into mg and k into mg, and only force which is supporting the motion is and g. So acceleration will be along this direction. This is equals to a. Now we will have mg minus of 2k mg is equals to total mass of the system is 3m. So this is equals to 3m into a, and a can be written as mg 1 minus of 2k divided by 3m. M and m will get cancelled. The value of acceleration will be equals to g by 3 1 minus of 2k. So for this case, acceleration should always be greater than 0. Here we have already taken that acceleration is not equal to 0. That means acceleration should always be greater than 0. So for this case, we will have a should be greater than 0. That means 1 minus 2k should be greater than 0. This will imply k should be less than 1 by 2. So in this case, if k is less than 1 by 2, we can also calculate t2. So if we take this as acceleration, we can draw the free body diagram of m2. So here we will have t2, and acceleration of m2 is in this direction, that is a, which is same as g by 3 1 minus of 2k. So we can write t2 is equals to mass of 2 is m into acceleration we have already calculated is equal to g by 3 1 minus of 2k. So this is the answer.